Hello, this is the first of two different videos addressing Algebra 1's last section of Chapter 2 dealing with percents. Now, before we get to the whole idea of percents, let's review and run it back to our previous section in terms of learning out how to solve a complex proportion. So if I zoom in on this guy and kind of focus in on the picture here, the idea here is we want to use our idea of cross multiplication, or simply cross multiply, to first set up our video, or to first set up our equation, and then ultimately figure out the number that we're going to work with. So when we do this, we use the distributive property to first show that relationship, and then we use our algebraic techniques to figure out what our variable value is. And so our equation will look like so: 12 times the quantity of 2x minus 3 equaling 3 times the quantity of x plus 7. Now, you may remember from a previous lesson I talked about if you have constants on the outside of groups and you know they're divisible by each other, you could divide them here. I wouldn't necessarily play into that in this situation. I would more or less focus on, hey, I need to get these values separated and ultimately get the variable by itself. And so always rely on good old-fashioned distributive property to make that happen. And so the next step is to literally work it out and then ultimately find x. So I go ahead and multiply my values. So in this case, 12 and 2 makes 24x. And then I'm going to take away 36, and then that's going to equal, come on now, it's going to equal 3x plus 21. Now, just like I was told in classes, I'm going to start streamlining my equation work, just so you guys are aware. And so this next line is going to come at you pretty intense. What I'm going to do is I'm going to add 36 to the 21, and so that's going to give me 57, and then the same line, I'm going to subtract 3x from 24 to make 21x. And then from there, my end game is to divide both sides by not 22, but 21. And so in the end, my value ends up being x equaling 57 over 21. Now remember, we don't necessarily want to have fractions per se in play here. And so I'm just going to punch it into my calculator, and I'm going to get a decimal of approximately 2.71. And again, that's rounded just for the sake of knowing what exactly we got going on. Now, main event, what are we talking about with percents? So today, the front half of this lesson is going to talk about how to use the percent proportion to set up equations and ultimately solve a wide variety of percent problems. So let's jump on in. So we can solve problems involving percentages by using either the root form of a percent, which is actually known as a fraction, or the percent equation, which are closely related. You can use a proportion to solve a percent problem if you write the percent as a whole number. And you'll see what I mean by that here in a moment. So if we take a look at the percent proportion is strictly saying I have is over of. And when I say is, I like to use the word part. Okay? Because we're figuring out a fractional piece to this. Conversely, on the other side of that fraction, we have of, which can be referred to as our whole value, okay? So is and of and part and whole are very interchangeable, but in the end, you really will want to get used to seeing the is and the ofs, because the problems you'll do in your practice set truly involve is and of, okay? This does need to be present for credit on your practice sets, your quizzes, tests, and ultimately a problem on your final. So how do we use is of set equal to percent over 100? We literally just plug our numbers in. So we know what percent, we're trying to figure out percent with these two examples. Okay, so I know the right side is going to be x over 100. But now I got to figure out, how do I make logic and sense of this guy? And it says, what percent of 56 is 42? So this tells me my is value is 42, and then my of is 56, and then I set that equal to what I'm trying to find, which is in this case is my percent. I set that as x over 100. Format should look familiar. It should be like, oh yeah, that's a proportion. They're set equal to one another. So I ought to be able to cross multiply, and that is correct. So I cross multiply and sets up a one-step equation. I end up with 56x equaling 4,200. And then I divide both sides by, so I have 4,200, and then I divide both sides by 56, and then that's going to give me my percent, which ends up being 75%. Looks pretty straightforward. Example 2 follows that same line of thinking. So again, what percent, so again, here's my unknown, what percent of 90 is 54? So another good point, my 54 is my is, my 90 is my of, and then just like before, I set that equal to x over 100. Cross it up again, and so that's going to give me 90 times the number x equaling 5,400. Now this one I can be less reliant on the calculator because each value has a 0, so I can cancel out a 0, and then ultimately I have 540 divided by 9, and so that ends up being, after I divide it out, you get 60%. Example 3. So what happens if we're asked to find other elements of our percent proportion? Well, when we're asked to do that, we can figure out other things based off of what's missing. And so let's say if you're given a of, or if you're given an is, we can plug those values in, cross multiply to figure out what these things are. And so there is my answer. Let's clean that up a little bit. I got a little carried away there. So let's take a look at example 1. It says 125% of what number is 17.5? So what do we have given? We have a percent value, we have an is, we already know percent is out of 100, and then we know what we're trying to figure out. We're trying to figure out the of. And so we can plug these values in. So my is, so I have 125% of what number is 17.5. So the left side of my equation will read 17.5 over some number x equals 125 over 100. Gosh, it looks like a proportion again, doesn't it? It certainly is. So we can go ahead and cross multiply. And so now here's where you might need your calculator for a little bit of advanced stuff here. 125x equals, let's figure out 17.5 times 100 is 1,750. And then I divide both sides by 125. And then x is going to equal 14. Now, this value won't have a label because it's a part of the ratio on the left side that does not have a percent attached to it. Last question. A little bit more straightforward thinking on this one. It says, what is 30% of 115? So here's my 115. My is unknown, and then I have a given percent. So again, set up my proportion. What is 30% of 100? Well, this time I'm going to write it backwards just because I have given certain values in the front here. So 30 over 100, and then my of is 115, and then my other value is x. Tell me if you heard this before. Let's cross multiply again. So we have 100x equals 3,450. Again, I can use my 0 over here to get rid of 1 0 for each and divide both sides by 10. And that is going to give you, it may give you 69.2, but again, remember in proportions, we want to use decimals for answer, 34.5. All right, so now, real life application time. We're going to talk about a common application. It's called simple interest. And basically what this is that it gives you the opportunity to earn money on any type of account, whether it be a checking account, a savings account, maybe it might be some stocks or some bonds, those kind of things. You get to calculate the simple interest here. Now, you can see the formula given here below. It says the algebra behind it is some letter I equals P times R times T. The interest is designed as I, and this is basically what is added to the principal amount in an investment. The P is the principal. This is the money that is initially deposited into said account. R is the annual interest rate. Now, it's going to come at you as a percent. So, for example, it may say the interest rate is 4 point, holy moly, this is going crazy. Let's fix that. So it might say the interest rate is 4.5%. But when we use it in a calculative sense, it's actually going to be inputted as 0.045. So remember, the decimal has got to shift 2 spots over from the left to the right to make this number being usable. And so then in the end, the last part of it is T is the time in years. So how are we going to use this? Well, if you take a look at the example, it says if you invest $50 at a simple interest rate of 3.5% per year for 3 years, the interest you earn is what? Well, here's my initial investment, $50. Here's my rate. Let's clean that up a little bit. So my $50 is my principal, and then my 0.035, that's my rate, my percentage rate, and then my T is my time. And so best case scenario is literally take your calculator, plug these things in, work it left to right. Make sure you write these values down so that I can see where your values are coming from as we should work through these problems. So wrap it up. Here we got an example. You deposited $840 in the savings account that earns a simple interest rate of 4.5% per year. And you want to keep the money in the account for 4 years. How much interest will you earn? So the I is what I'm trying to figure out. And I deposited $840 into an account that earns an interest rate of 4.5%. So that means it's going to be 0.045, and that's done over 4 years. So again, this is what I want to see from you on your practice set. I want to see this stuff right here. So now let's end this problem. How much interest will I earn when said and done? So I come to my calculator, I'm going to put 840 times 0.045 times 4, and that's going to end up giving me my final value, which is $151.20. Don't be surprised if on a quiz or a test I may say how much money is in the account in all. And so if that was the case, you would simply take $840 and add $151.20 to it. And so in the end, you would have a total of $991.20 in the account. So that kind of puts a wrap on day number 1. Please check out Google Classroom for the practice set that focuses on the front half of this section, and then also notice the assignment for the practice set number 2. Till next time, have a great day.